Now let's talk about increasing speed, speed of delivery, which is productivity. Okay. All right. So as we turn our attention to increasing speed, let's go over a few things. And by the way, this is quite a bit of information to digest. Before we talk about productivity, because we've gone through a lot of things and we're just now getting into productivity, but really for good reason. With quality problems, our team is diverted to diagnosing and fixing the bugs rather than working on new changes and features. And with stability problems, our team is yet again distracted from actually working on new changes because the production environment rightly takes priority. And even if we staff dedicated systems engineers to be responsible for supporting the production environment, they typically can only operate a stable system. For high scale systems, it's normal to constantly be changing the number of servers or cloud CPUs or Kubernetes pods based on the load. And it's normal to be watching the queue length as data flows to be able to be sure that those messages are being processed within the established SLAs. But when errors are happening and when the system is not behaving as the systems engineers have been trained to expect it to behave, then those issues are just escalated back up to the software team. And this is where development capacity goes. The power of prioritizing quality and stability first is that the result is 100% of your team's capacity actually goes to the new work set before it. And with this as a achievement, then we can look at what then causes a team to be able to move fast when it's actually able to work on new software changes. From an oversight perspective, I'd like to paint a picture of how to think about your team's productivity, or say throughput or pace. So let's take an analogy of the Baja 1000 desert race. To do well in this race, you need to finish. That means you need to pick a pace that will not cause your drivers or your machine to expire, to break down. And then you need to navigate it well. If your drivers get lost or go off course, they may drive many more miles than necessary, run out of fuel. So picking a good course and staying on that course shortens the miles necessary to finish the race. And even so, an obstacle may emerge and likely will emerge that needs to change the course they're traveling on because of new information that they learn while driving. And finally, the drivers must drive fast along the chosen route. Now let's apply this analogy to the software team. The team alignment template has given us a tool to ensure everyone is clear on where we're going, and that is what business outcome we want to achieve. This is the finish line. Feature A or feature B is not a finish line. Any individual feature is akin to a particular route on the race course. And we're choosing feature A because we reasonably believe that changing the software in this way will push us towards our chosen objective. But as we move along, we need to watch out for new information that would help us learn that maybe feature A might not be the progress toward our objective that we hoped it would be. Okay. So let's pause now and tackle a fallacy that's been promoted heavily in our industry. And that fallacy is that of the product owner. The Scrum curriculum heavily touted the product owner as the role that knew the customer so well that he was the one. Only he was the one to prioritize the backlog with items in the correct order. And because the product owner had prioritized them, these features were deemed to be the right software changes to make. In practice, so few teams have been able to find a person with that good of customer knowledge that the role of product owner hasn't worked for our industry. The 2018 State of DevOps report by Puppet Labs shared a study that teams using product owners had a batting average of about 1/3, 333. And in other words, the product owner was right about 1/3 of the time. When the changes were put into production, they yielded the desired outcome that was wanted. What's interesting is that another 1/3 of the time, the changes put into production yielded no progress towards the desired business objective. And the final 1/3 of the changes actually hurt performance of the software and moved the business away from its objective. These changes had to be hurriedly backed out. Okay, they were hurting things. Now, in your oversight role, don't rely on anyone to be so prescient that you trust them implicitly to decide what changes to prioritize. Instead, think about it like any other department in the company. Measure the result and adjust based on the actual data that you collect. And this is another reason for prioritizing stability ahead of moving faster. The same practices that achieve stability yield a capability for collecting data used in business analysis for what features yield a desired result. Now, now that we have a good mental model for how to increase speed towards a goal, we need to measure the current actual speed. All right. You'll want to add more measures to the team's scorecard, add weekly numbers that represent progress towards the business objective of the software. And if the software is related to, say, e-commerce, you may add daily revenue. If it's an inventory system, then you may add numbers that are reported on executive team scorecards around inventory and warehousing. This gives your software team ownership of targets that other executives see that are important outside the software team, important for the business. And then they can participate more fully in improving those business measures. So when it comes to software specific measures for the scorecard, I do suggest these as a minimum. First, desired number of issues delivered per week. Next, current number of issues that are being delivered this week. Next, the average time an issue spends in each of the statuses. Okay, that's progress. Now, if you're just starting this type of measurement, you might not know what target to set for the desired number of issues delivered per week. That's fine. Go ahead and defer that until you've measured actuals for probably about a month. An important principle on which these measures are dependent is commonality. Okay. Now, let me give you another example. The shipping industry is able to deliver any size or shape of object to a destination. And this is because they have packaging standards. There's envelopes, there's small boxes, there's long tubes, there's pallets, and even shipping containers. And in software, no two features are the same either. But yet the shipping industry has figured out how to send ships with just a bunch of shipping containers. So at the ship level, they don't care what size they are. Now, in previous decades, and still today, software teams have attempted to treat every software as unique and then estimate. And they've tried different methods of estimation to get to numbers that could actually be relied on to figure out how much work was in the backlog. But no method of estimation today has actually succeeded and reached that goal. And let's take an example. If our work tracking system has some features in it that are 10 times or 5 times or 2 times the size of other smaller features, then it's hard to get the team into a flow of consistent delivery. And again, other departments that measure throughput know that the work needs to be made common size in order to empower the team to shine and deliver at an increased rate. In software, the practice to embrace is feature decomposition. In project management, there's a practice of work breakdown structure. Breaking down units of work into smaller tasks is used widely elsewhere to make the work more approachable as well as manageable. Feature decomposition is the work breakdown structure in software. So guide the team to break down software changes into tasks that can each be reasonably completed in one day of effort. For some features, you're going to be challenging the intended design in order to accomplish this. The result will be development tasks that are all roughly one day of work in the size of labor. Okay. And with a common sized unit of work, you can measure the throughput of your team. But measuring throughput isn't the only reason for doing this. Large software changes that are not broken down are typically where other problems exist. Faulty analysis, undefined architecture, incorrect assumptions, and undiscovered unknowns. Breaking down development work ends up exposing those hidden problems and further increases quality of what is delivered. Breaking down the work forces more design work upstream of the coding activity because design decisions will have to be made before initial code is written. Starting writing the code on a feature that's already too large, it mixes missed analysis and design conversations right in the middle of unfinished code when the developer gets to a point where he finds an unanswered question. Then he has to stop coding, take hands off the keyboard, and then have an impromptu meeting that has to happen right then because coding on that feature is now blocked. And you can safely assume that a feature or change that is expected to take several days to complete will not take several days. It'll take 2 times that, or 5 times that, or 10 times longer than that. The several days estimate, that's really just an estimate of no confidence. Only when you have an estimate of 1 day can you be certain that all needed work has actually been identified and understood well. And in this process, you'll also see more detailed design diagrams since more knowledge will be flowing throughout the team. And as you increase the team's delivery speed, here are some minimum practices to expect to have implemented. A Kanban style work tracking board. That's a work board where items move from left to right. Next, feature decomposition or work breakdown structure. Third, design diagrams for everything. And then fourth, refactoring. Now, the last item on the list, refactoring, that's a mature practice. You can find some good books on this practice, and it recognizes the reality that since we're going to learn from how our users use the software after the software has been built, then we need to expect more changes based on that learning. Refactoring is our method for making those changes. And we're going to learn that, say, a feature should behave and be designed differently once it's in production. Refactoring is a means by which we change the software so that the feature becomes designed in a new way, as if we had been designing it that way from the start. And here's a suggested question to ask for when you learn something new from users in production. So, since we need to change feature A, what parts need to change? What parts in the software need to change so that the outcome is as if we had intended to design it this way from the start? Now, the lack of refactoring that happens, it will compound over time into a code base that is hard to understand and hard to follow. Refactoring ensures that the code is always easy to understand at a glance. And as you measure your team each week, look for the current number of issues delivered each week to increase. You'll also notice bottlenecks to increased speed on your Kanban style board because you're measuring the average time an item takes in each of the statuses on your work tracking board. And when bottlenecks are discovered, you resolve them. The lack of tracking time per status, if you don't do it now, that's what allows bottlenecks to stay hidden. Okay, with all this, you have a very strong oversight position and responsibility for your software team. It'll be important to keep quality, stability, and speed in the proper order. Okay. Schedule pressures, they can tempt teams to forget about this order, to allow quality and stability to slip by, tolerating shortcuts, taking shortcuts. Okay. But it doesn't take long for shortcuts to accumulate, resulting again in poor delivery speed. Like whenever a bug makes it out to users or whenever production issues happen, reinforce to the team the importance of taking action so that this kind of bug or issue can never happen again. It's a logic journey. For a bug or issue to not happen again, it's not just about the team trying harder or gritting their teeth tighter. It's about real root cause analysis and changing the problem at the root so that it's impossible for the bug or production issue to happen in that way again. Okay? That's the way to be thinking.